Hi everyone. Today we start exponential equations. Of course, when we talk about exponential, basically it's about exponents. Yeah, when we talk about exponents, we mean powers. Exponent is just another name for power. We can say power, we can say exponent. Yeah, then we can also say index. And it's because of the word index, we have indices. All right. So the first one says 3 to the power x equal to 9. We want to find the value of x here. 3 to the power x equal to 9. Well, basically, fundamentally, when you want to find the value of a letter that is acting as a power, that is acting as an exponent or an index, yes, primarily, we always want to see that the two bases are the same. We always want to make sure the two bases are the same. Once the two bases are the same, we can implement the rule that says if a to the power x is equal to a to the power y, a to the power x equal to a to the power y, provided one term equals to one term. If the bases are the same, we forget about them. Then we say x equal to y. So this one is for exponential equations, basically. So here we want the basis to be the same so that we can implement this rule. But by the look of things, the way they appear, they are not the same. But we can generate this one to give us a base of 3. So this is 3 to the power x as it is given. 9 can be written as 3 to the power 2. Why is it 3 to the power 2? Because 3 times 3 will give us 9. Now we have this format where the bases are the same and it is one term equals to one term. So this and this, we can forget about them. Then we say x equal to 2. This is the result we have. The second one says 4 to the power x equal to 64. 4 to the power x equal to 64. Okay. One term equals to one term, but the power is where the unknown lies. So what we want to do is to make sure that we have the same base. This base we have here 4 is for us to get the same base 4 here. Or if you think you cannot get base 4 here, but you can manipulate in order to have equal bases, no problem. It is still all right. So here is 4 to the power x. So which number we can raise to, which number we can have as a power of 4 so that we can get 64. What I'm trying to say is, since we want the two bases to be the same, this is base 4. So here you want the base to be 4. So what number do we raise? We use here as a power. For example, 4 to the power of something to give us 64. If we say 4 to the power 1 is just 4. 4 to the power 2 is 16. 4 to the power 3 is 64. So we use power 3. So base 4, base 4. One term, one term. This goes with this. So x equal to 3. But another student may not think of 4 because, whenever we have 4, some people will quickly think of 2. Well, no problem. If you have 4 to the power x, you can say for just 4 is 2 to the power 2. But there is x at the top. And 64 is 2 to the power what? 6. So this takes away this. Then we say 2x equal to 6. We need x. We divide both sides by 2 by 2. So x is what? Is 3. You will still get the same thing. So the most important thing is the bases are the same. That is all what matters here. So the third one says 4 to the power 5, 4 over 5 raised to the power x minus 1 equal to 1. One term equals to one term. But The power is where the unknown lies. The unknown means the value that we cannot quantify. We don't know the quantity. We don't know what it represents. You don't need to ask someone to tell you what 4 stands for. You know, when you say 4, 4 items. Yeah. When you say 5, you know exactly how many or you know exactly the quantity. 1, likewise. But here, X, we don't know. X could take any value when it comes to mathematics. The reason we call it the unknown. All right, so when the unknown is the power or the power is the unknown, one term equals to one term, we always want to make sure that the bases are the same. But think of this base as a fraction. How can we get the same base here? Well, it is always easy when you have 1 and you wish to have a certain or a desired base. It is always easy. Why? Because any value raised to the power 0 is always 1. So if we have 1, so given here 4 over 5 to the power x minus 1, and this is 1. But our aim, our target is to have the same base. The base here is already 4 over 5. So we say 4 over 5. There is no number you can use here as a power to give you 1 except you say 0. Remember, any value raised to the power 0 is 1. Now the bases are the same. This takes away this. So x minus 1 is now 0. So x is equal to, here is 0, so we'll move this to the other side, it becomes 1. So we come to the fourth problem that says half equal to 8 to the power x. All right, one term equals to one term, and the power is the unknown. So we always think of exponential functions, exponential equations. All right, so we want the same base. Here is 8. How can we get a base of 8 here? It's not that easy. It requires a lot of tedious mathematics manipulation, because I don't just want to say it's not possible, but mathematics, we can take certain length in order to make what seems to be impossible to be possible. Basically, it sounds or impossible. All right. So 1 over 2 can also be written as 2 raised to minus 1. Remember, 2 down here has the power of 1. And when it goes up, the sign of the power changes. So here is 8. So the fact that our aim is to have the same base, 8 can give us a base of 2, but with a power of 3, because 2 times 2 is 4, 4 times 2 is 3. So there is x there already. So this and this are the same. One term equals to one term. If you have something like this here, like 2, you cannot cancel. You cannot do anything. So one term equals to one term. So here is minus 1 equal to 3x. We need x. We divide by 3. We divide by 3. So x is equal to minus 1 over 3. So thank you for watching. Do not forget to follow, like, share, and comment. Also subscribe to the YouTube channel. See my next video.